Hello everyone, welcome back to the course on cryptography and network security. Myself, Dr. Janardhan here. So in today's session, we'll try to understand how the AES encryption we're going to be performed. So in the case of the round 1 of 4 transformations. So in today's session, we'll try to understand how the plain text and the key which we are going to be used to convert that into a ciphertext. Then the very first step, initial state matrix formation. So whatever the 128 bits of plain text will be there, so that we are going to be representing in terms of 16 bytes, and that we are converting into an 4x4 matrix. Then we try to perform the AddRoundKey, substitution bytes, shift row, and the mix column, and finally the results of after one round. So in today's session, we try to understand only after completing the one round. So what will be the equivalent ciphertext for the given plain text we try to understand, and at last we try to understand the key insights of today's session. So learning objectives: by end of this session, the learners will be able to apply the AES transformations on the given data. So they will be able to perform the substitution bytes using the substitution box. Then they will be able to perform the shift row operation and also the mix columns correctly, and understanding how AddRoundKey is going to be integrates the key value. At last AES, we are going to be solving one problem on AES step by step. So in this class, we try to understand the problem statement. We are going to be considering this plain text 128 bit we are going to be representing. So in a series of bytes, so it contains 16 bytes are there. So and even the key value is of size 128 bit. Again, we are going to be representing in the form of bytes. Total 16 bytes are there. Now we perform the one round of AES encryption. The very first step is, so when we have 16 bytes of data, so that we wanted to go and convert in the form of 4x4 matrix. So we are going to be read the entire 16 bytes in the row form. The first 4 bytes I'm going to be representing in the very first column. The next 4 bytes of data we are going to be representing in the second column. So then the third set of 4 bytes I'm putting in a third column, and the last 4 bytes I'm going to be representing in the fourth column. So this is how I'll be going representing 4x4 matrix. Then whatever the key we have, 128 bit, so that also will be go on representing in the form of 4x4 matrix. We just go on performing the simple XOR operation. So this is the very first step. So that is we called as an initial transformation. So we are going to be take 32 and the 2b. We are going to be perform the XOR operation. We will be able to get 19. So all these numbers in the form of hexadecimal. So we are going to be convert that hexadecimal into binary format. So then we have to be go with a bit by bit transformation. So once we perform, the very first step is initial transformation. So that is AddRoundKey with a state matrix. We have to be perform the XOR operation. When it comes to the step 2, whatever the values we have, the output of the very first step. So we have taken only the first column values of the previous step, that is 19, A0, 9A and E9. So these numbers I'll be go on representing with respect to substitution box. I'm just go on replacing these numbers with respect to substitution box. So how I'll be go on reading the value which is available in the 16 cross 16 table. This is we called as encryption S box, the forward S box. So we are going to be make use for inverse. So when we go for performing the decryption operation, so we'll be go on having this 16 cross 16 S box in the form of inverse. So now the 16 is get converted into D4. So the 1 we are going to be considered as a row element, and 9 we are going to be considered as a column element. So where the 9 and 1 is going to be intersect, that is the corresponding value of that 19. So that is D4. Similarly, when I come to the second number A, so A will be the row element and 0 will be the column element. So A and 0, I'm going to be get the value as E0. Similarly, 9A, 9th row and A column. So I'm able to get 9A, B8. Then E9, E row, 9th column, 1E. So this is how all the numbers in the previous step. So what we have 4 cross 4 matrix of all the elements, we are going to be converting into the equivalent value which is available in the substitution box. So this is the answer we are going to be get D4, E0, B8 and 1E. So here 19, A0, 9A, E9. So we convert it into D4, E0, B8, 1E. Similarly, the other elements also we have to be going to replace by representing the S box. Now, in the case of third step, that is third transformation. So that is we call as a shift row. So whatever the output we got from the previous step, that is substitution box. So I'm going to be keeping the first row as it is without any kind of modification. The next row, I'm going to be shifting circular shift by 1 byte. So the elements will be get changed. Next, the row 2, that is here. So I'll be going performing 2 byte circular left shift, and the last row 3 bytes circular left shift. So after performing, I'm going to be able to get the output, this one at stage 3 after the shift row. So now we have to be go for mix column. So this is the output which we got from the previous step, that is after the shift row operation. So now we have to be perform matrix multiplication when we go for mix column transformation. So column by this matrix. So one column I will be going performing with respect to this matrix. This is a standard matrix multiplications we have to perform it. See here, the one row which we are going to be multiply, I'll be able to get the new elements in the first column. The second column is multiplying with this matrix, I'm able to get the new second column, similarly third and as well as the fourth. So this is how we are going to be performing, and after the mixed column transformations we are going to be get this is the output. So now we try to understand. So AddRoundKey, substitution byte, shift row are simple compared to mixed column operation. So when we come to mixed column operations, we have to be go and perform a little calculations in order to get the corresponding values. Now, so in this case, in this problem, so from the previous one, I'll be considering the first column D4 BF 5D 30. So this column is get multiplied with a standard this one. So the first row element is multiplying with this. Okay, then again in order that will be the first element value. So in order to get the first element value, so we have to be go and perform like this. Next, if I want to be get the second one, if I want to get the second one here, so then again I'll be go on multiplying with the second row element with the this column same. Similarly, third row element with a same column and the last row with same column. So then I'll be able to get that is 04, 66, 81 and E5. So likewise, the other elements of the previous output we have to be multiplied to get the corresponding second, third and the fourth column values. So now we see how to go with respect to the first element, how I am able to get this 04. So in this class we try to understand how to get this 04 by multiplying with the standard matrix with the first column elements. So now what I'll do here, so I'm going to be multiplying 02 into T4 XOR then 03 multiplies with BF value then 1 into 5d XOR 1 into 30. So now first try to convert the value. So it is not a simple hexa multiplications at all. So we have to be gone convert these numbers into polynomial equation. So 0 to representing in the form of binary of 8 bits 0 0 0 0 0 0 0 1 0. Similarly D4 1 1 0 1 then 0 1 0 0. So this I'm going to be represent in the form of polynomial function. So that is x to the power, so 0 is there, 7 x to the power of 7, 6, 5, 4, 3, x to the power of 2, x to the power of 1, x to the power of 0. So now I try to understand 0, 0, 0, 0, 0, 0, 1 and 0. So now whatever the element 0 are there, we are going to be neglecting it. So only whichever it is there as logic 1 that I'm going to be considering. So this is now x. Similarly, I'll be going performing x to the power of 7, x to the power of 6, x to the power of 5 is 0 is there, so I'm not going to be including x to the power of 4, then x to the power of 3 is not there, x to the power of 2 is there, then x to the power of 1 is also not there, and x to the power of 0 is also not there. So I'm going to be include only this much. So now I try to multiply x, that is 2 corresponding polynomial value, x into x7 plus x6 plus x4 plus x2. So I'm able to get x8 plus x7, x5 and x3. So we have total 8 bits. So we have to be keep the values into the 8 bits. So this is greater than 8 bit is there. So I'm going to be used to convert this x to the power of 8 into the equivalent 8 bit numbers. So I'm going to be applying irreducible polynomial function. So that is x to the power of 8 I'm going to be converting into x to the power of 4 plus power of 3 plus x to the power of 1 plus x to the power of 0. So this is how I'll be converting this 4 3 x plus 1. So this I'm going to be including in this case. So now what will happen is, so x to the power of 4 plus x to the power of 3 plus x to the power of 1 plus 1 plus 7 5 and 3. So the repeated terms I'm going to be cancel out. So x3 will be get cancelled. The rest elements will be x to the power of 7, x to the power of 5, x to the power of 4 plus x to the power of 1 plus 1. So this now I'll be converting into binary form. So that is 1 x to the power of 7, x to the power of 6 is 0, x to the power of 5 is there, x to the power of 4 is there, then x to the power of 3 is 0, x to the power of 2 is 0, and x to the power of 1 is here, and x to the power of 0 1. So now I'm going to be converting this into equivalent hexadecimal number, that is 1011 means B and 0011 means 3. The corresponding, so 2 into D4 when I perform the multiplication by making use of polynomial equation, so I'm able to get B3 is the answer. Next, we try to understand 3 into BF. So 3 into BF, I'll be go on representing this 3 into binary form 0 0 0 0 0 0 1 1, that is nothing but x plus 1 I'm going to be represent, then BF, that is 1 0 1 1 1 1 1 1, that is nothing but x to the power of 7 plus x to the power of 0 is not there, x to the power, x to the power of 5, x to the power of 4, x to the power of 3, x to the power of 2 plus x to the power of 1 and x to the power of 0. So all these things I'm going to be including it. So I'm going to be represented as 5, 7, 5, 4, 3, 2, x plus 1. So now I'm going to be multiplying this with x plus 1. So first I'll multiply with x. It becomes x to the power of 8, x to the power of 6, x to the power of 5, x to the power of 4 plus x to the power of 3, x to the power of 2 plus x. Then when I multiply with 1, so all the elements will be get repeated. That is 7, 5 plus 4 plus 3, then plus x to the power of 2 plus x plus 1. So now I just wanted to cancel out the repeated elements. So here x gets cancelled, x square gets cancelled, x to the power of 3 and x to the power of 3 will get cancelled, 4 also get cancelled, 5 is also get cancelled. So finally I'm going to be get x to the power of 8 plus x to the power of 7 plus x to the power of 6 plus 1. Now again x to the power of 8 is there. I'm going to be converting this into the irreducible polynomial function, x to the power of 4 plus x to the power of 3 plus x plus 1 plus x7 plus x6 plus 1. So I'm cancel out 1 and 1. So finally x to the power of 7 plus x to the power of 6 plus x to the power of 4 plus x to the power of 3 plus x. So this I'm going to be converting into the equivalent binary function values. 1, 1, x to the power of 5 is not there, 4 is there, 3 is there, 2 is 0, 1 is there, x to the power of 0 is not there. So I'm going to be converting this. 1101 means DA, 1010 means DA. So that is nothing but if I multiply 3 into BF, I'm able to get DA. Next, the remaining. So 1 into 5D, I'm going to be get 5D only the answer. Then 1 into 30, I'm going to be get 30. So after this, so whatever the values we have to be go and perform XOR. So 2 cross D4 value is B3. So B3, B into 3 into BF is DA, 1 into 5D is 5D, and 1 into 30 is 30. So I have to go and perform the XOR operation with all these numbers. I'll represent 1 0 1 1 0 1 0 1 1 1 1 0 1 1 0 1 0, then 0 1 0 1 1 1 0 1 30 0 0 1 1 0 0 0 0. So now, so performing the XOR operation, even number of ones are there, then the output will be 0. Odd number of ones are there, then the output will be 1. So here in the case of first, so 2 ones are there, so even the output is 0. In the next case, 1 and 1 is there, 0. In the third case, only 1, that is odd number of 1 is there, then the output is 1. Next 0. In the next case, all the 4 ones are there, 0. Next 0, next 0, the next 0. So I'm going to be converting this for the output. So after multiplying this, I'm able to get the answer as 0 4. So we are going to be proving that when I multiply with this, the answer I'm going to be get as 0 4. So here whatever the example we have shown, so when I multiply with this, I'm able to get as 0 4. So this is how you need to be applied. Once again, in order to get to 66, 81 and E5, so take the element of this D4, B5, BF, 5D30 with second row element, and third row and last row you are going to be get 66, 81 and EF. So my dear students, you try to apply the same method, so in order to get the output of the first round. So this is how the output of one round AES after completing add round, substitution bytes, shift row and the mix column will be able to get the round 1 output of the given plain text. So this output will be go and work as an input to the next round. Again, add round, substitution byte, shift row, mix column is going to be work. So similarly, by completing all the rounds of operation in the AES, we are able to get the first cipher block of the given plain text. So with this, I'm going to be ending the today's session. So please try to practice of solving this example. Thank you.